Hello, welcome to LiDAR Lab. I'm Lewis Graham, Chief Technical Officer for QCoherent Software and GeoQ Corporation, the parent company of QCoherent. Today we're going to look at the basic ground classification in LP360 Advanced. So this is automatic ground classification. We're going to do a couple different sessions on it. This first session is devoted to just doing the basics of ground classification. So I've got LP360 Advanced loaded into ArcGIS. I can check on my license level by clicking on Customize Extensions. You'll see the LP360 extension, and here parenthetically I have the license level. So I am at the Advanced level. The first thing you're going to want to do is check on a couple of settings in ArcGIS and LP360. First of all, make sure you've got units set, and you can do that by properties on the layers in ArcGIS. My units are meters, and I know that that's correct for this data set. It should be set automatically, but sometimes the LiDAR files do not have geospatial reference systems correctly encoded. The second thing I'm going to want to check is look at the laser files and ensure that the LiDAR files are loaded for read-write. So you can click on the LAS files icon in the table of contents, and you should see a green lock on each of those files. If not, right-click and open all files for read-write, and also load all files. And then finally, we're going to want to look at the Pointcloud Tasks tab in LP360. The Pointcloud task that we are interested in is ground classification. So click on Pointcloud Tasks, add a task, and notice that we've conveniently come to Adaptive 10 ground filter. And you can give this a local name to store it into your table of contents for Pointcloud tasks. I'm just going to call this my ground and say OK, and my filter selection is switched over to my ground, and I've got parameters that are used for setting ground classification. We'll go through all of these classification parameters and how they're set at the basic level in just a moment. But we need to do a little bit of preliminary analysis on the LiDAR data that we're using. So I've loaded some LiDAR data from Escambia County, Florida into ArcGIS, and I'm displaying currently by elevation, not modulated by intensity. So I'm just displaying color-coded based on the elevation. You can see trees, we can see what looks like some water networks. Maybe a little misleading, it's coded in blue meaning low, which also happens to be a watercolor. Here I can modulate by intensity shading and get a much better idea of what we're looking at. So indeed it does look like we're looking at some water features here in this in blue. We have some road features, buildings, obviously the red is trees, etc. If I display by class, then you notice that my data are not classified. Everything is showing up in gray, which is the color I've been using for unclassified data. That can be changed with the symbology settings in LP360. Now, data are best classified if you've got multi-return laser data, and we can test that by switching our display to display by return combination. And here we see that we are showing different colors, so we have multiple return data. We can inspect this by selecting the Inspector tool in ArcGIS, or the Identify tool, and click on an area of points where we see multiple colors. And you can see that for the particular point that I picked, I have return 2 of 2. So this particular laser pulse had 2 returns, and I'm looking at the second return. So that's good. Multi-return laser data typically occurs when we hit semi-transparent foliage and that sort of thing to the laser beam. So the laser travels through the foliage of a tree. Part of the beam is returned to the laser sensor. The beam travels on down, we hope, to the ground, and the final return comes from ground. So we're ready to set some parameters. The first thing we want to set in our ground classification are the source points. So these are going to be the points that are used in the classification. I bring up my dialog, and you notice that in classification I have for sources use all points. Typically I would not want to do that. Typically I would only want to consider the created never classified and the unclassified for consideration as being ground points. So I'll clear all these checks, and now I'll simply check class 0 and class 1. Return combinations. If I have multi-return data, I want to select last returns because it is the last return that is most likely to have reflected from the ground. Return 1 of 2, for example, probably came from a tree limb or some other elevated surface. So select last returns. If you don't have multiple return data, you can also use last returns, and that should give you the correct answer, or you can use all returns. We'll keep that at last returns. Make sure that elevation range is not set, that intensities are include all, and that flags are all set to ignore. OK off this dialog, and now we've got our source points set. Where would you like to put the classified points? Almost always that's going to be in the ground class, so you can hit the drop down if you want to change that to a different class. Sometimes you might put it in a reserved class if you're doing some kind of an experiment. Next, you want to set units on your dialog to correspond with the units of the map. Here we have our map units in meters, so we'll set our units on the Pointcloud task 2 meters. Now this units on Pointcloud tasks is a matter of convenience. If you fine-tuned an algorithm, say to work in feet, and you don't want to change it when you use it on a different data set, then you can keep the units set to feet, and LP360 will automatically recompute units based on the current map unit. So that's the whole purpose in this units that you see on the Pointcloud tasks. We're going to want to use standard settings in this session of tutorial. In a future session, we'll look at how to set the advanced parameters. However, it's always a good idea to check advanced and make sure that something hasn't been previously set and is stuck and you have surprising results. So you'll always want seed point selection set to generate seed points, node insertion parameters set to use automatic parameters, and finally iteration control you'll want set to perform iterations. And so if those are all okay, we'll go back to the standard settings and we'll talk through these parameters. The first one is the most important. This is the seed sample distance. To classify ground in LP360, we superimpose a virtual grid over the data, and the size of that grid is determined by this seed sample distance. So if I have this set to 200, I'm going to superimpose a virtual grid over the data that is 200 meters by 200 meters. Within each one of those grid cells, I'm going to do some calculations to determine which point of all of the millions of points that could be in that grid cell is most likely ground, and I'm going to call that a seed point. From those seed points, 1 per cell, I'm going to generate a triangulated irregular network. I'm then going to look at all of the rest of the points in an iterative process and see how well they will fit into this initial 10, and that's why we call this algorithm an adaptive 10. There are 2 parameters that I use when I do that test. The first one is how far is the candidate point from the 10, and if it exceeds a threshold, I won't say that it belongs to ground. And the second one is that if I included it in the 10, I would have a new 10 face or facet. And what angle will that new face make with respect to the existing 10? And if that angle exceeds another threshold, then I'll say it's probably not ground. So those are the 2 tests that I make. So the important thing on seed sample distance is to keep it generally as small as possible without including features that should not be in the ground class. And those features are typically buildings. So I do have some buildings in this data set, and I'll need to know how big of a seed point I need to keep from including in the data set. So let's look at the width of one of these buildings. Just needs to be approximate, doesn't need to be precise. And you see that this building is approximately 12 meters wide. So if my seed size is larger than 12 meters, then I know that a grid will contain partially this building and partially the ground around it. And I'll probably select ground for my seed point. So I want this to be larger than 12. So let's go to 20. That should give us a comfortable margin. Again, on node insertion, automatic parameters. And finally, there's perform iterations. So after we've generated our seed surface, we'll make a pass through the data. That's called the first iteration. And we'll do the test that I mentioned earlier and add points to the 10. When we've checked all of the points in the surface area that we're trying to classify, we'll take a second pass through it. That'll be iteration 2, and so forth and so on. We stop doing that process when we've either hit the number of iterations that you specify as max iterations, or no more points were added to the ground surface in the previous pass. Now I always like to start this out fairly small, let's say 4, so that I can get an idea of what my settings are going to do without having to spend a long time waiting on the algorithm to complete. After you've set all of the parameters, make sure that you press apply. This is one of the biggest mistakes in Pointcloud tasks, and it is telling me that I probably ought to have our developers change this interface. If you do not press apply, you'll be using whatever the prior parameters were before you changed filter settings. I'm going to change my display back to visualize by class instead of point return. So here we are back to the gray. And now I want to actually apply this task, and I do that using the Pointcloud task toolbar. That's this toolbar. If you do not see this toolbar displayed, right click in the toolbar area and you see the selection of various LP360 toolbars, and the one that we want is LP360 Pointcloud tasks. The Pointcloud task I'm going to use is the one on the far left, which is execute task by envelope. I click that tool, left click in the map, drag a rectangle, release the left button, and the process begins. You can see a status in the lower left of the display. It ran fairly quickly. Now the best way to check how well this classification worked is to look at it in profile view. So I'll click my profile line tool, and I'll draw a profile in the map. Change the classification or the view in the profile to classification if that's not where it came up. And here the way I've set my symbology is I have ground points in orange, all other and the unclassified in gray. And as you know, you can simply mouse the wheel or wheel the mouse through the map view and have a look at how well we did this classification. So this looks pretty good. You know, I've left the building roofs out. They're fairly cleanly defined. They've not been classified. I have, in some areas of the ground, I might have a few points that weren't included. You can see that in this area, for example. And those points would probably be included if I ran more iterations than 4. But overall, this classification has performed quite nicely. You can see trees left out of the classification, buildings, etc. Ground fairly nicely classified. Let's see what effect we have if we change the seed size. So we will look at the manual classification toolbar, and there's an undo button. I'll simply undo the current classification. And now I'm going to change my seed size to something small. Let's say 4 meters. Again, remember to hit apply. Again, I'm going to do the drag rectangle task, type. I'll drag a rectangle and let this classify. And now you see when I look in the profile view that I've picked up points that are on the roofs of buildings, a few in trees, etc. And that's the effect that we have from making our seed sample size too small. So what happens if we make the seed sample size too large? In flat terrain, such as what we're looking at in this particular example, remember this is Escambia County, Florida, not much. So a large sample size really has no detrimental effects, and I could come in and say, make my seed sample size 200. Remember, apply that parameter. I'll undo my previous classification and drag another classification rectangle. And when that completes, we'll see that we had a classification that's quite similar to the prior classification. But in general, you'll want your seed sample size to be just slightly larger, let's say by 25%, than the buildings that you're trying to miss in the classification. That's the most important criteria. A large seed sample size can cause some problems if you're in quite hilly terrain, because you begin to span valleys and you may miss part of the data that you're wanting to classify. So that's really that's it. Automatic ground classification using the standard techniques in LP360 Advanced is quite simple. Seed sample size is the most critical parameter. I suggest you play with that parameter using a small number of iterations until you get the desired results, and then apply it using one of the point cloud methods to a rectangle, polygon, or to the entire project. If you have any difficulties with ground classification, you can send questions to support@qcoherent.com. Thanks very much for participating in this session of LiDAR Lab.